Another feature that this tool has is a heat map. And this heat map will show you how many times a part of an object has been seen by cameras. And it will also show you an angle heat map. And this angle heat map is really important because it ties very closely into how Master actually does material predictions. And if you've watched any of our previous tutorials, particularly the tutorial on ring flash, you'll see that I sometimes reference this idea of painting an object with light. And this is a way to actually visualize that effect of painting the object with light. So it'll make more sense when we bring up these tools, but in order for us to activate these tools, we need to import a 3D scene. And we'll want to import an Alembic file to make sure it actually has a mesh and to make sure it has cameras. So we can go over to File, Import Alembic, have some example objects here. We'll pick something, so we'll grab our red box and we'll click Import Mesh. And what that has done is it's not only imported the mesh, but it's now also imported all of the cameras. The first thing you'll notice is it's a little bit crazy, this scene right now. Like, it's very hard to see the mesh. We don't want to hide the cameras in the editor because then we won't be able to use them. So what I'm going to do is just actually change the way we're displaying them. I don't really care about seeing all of the camera matrices. So I'm just going to hide that. The other thing I'm going to do is just grab the entire scene and just orientate it so that this will make moving around the viewport a little bit easier. Cool, so we can now look at our box. We will have to select the mesh in question. And then what this will do is it will analyze the mesh and it will show us a heat map. Now, the more cameras and the more vertices that you have, the longer this process will take. So depending on what kind of quality you're looking for, we do have a way to simplify the mesh here. So I'm going to start off by just doing analyze mesh. And what this will do is it will start to run through all of these cameras. Now, this is going to take about 4 minutes for this object, but if I wanted this to run really quickly, you can simplify the mesh and this will probably get done in under a minute. If you have a really heavy mesh with like lots and lots of vertices and lots of cameras, and you want to see it at like the highest quality settings, you can leave it as is and it might take, half an hour. It can take quite a long time sometimes if you do want something to be very detailed. But for this particular object, it shouldn't take too long. This is now complete, and what it has done is it's completely analyzed the mesh in a few different ways. So the first thing we're going to look at is the coverage. So if we click Show Coverage Heat Map, that's going to show us where this object has and hasn't been seen. So it's been seen a lot by the top. So we can just see our scale here. This is scaling from 40 cameras as our minimum and 600 as our maximum. So anything above 600, you're pretty good. Below 40, it's not great. You can edit this if you want. So if I do update, it will just change the display here. You don't want to click this button because it will redo the analysis process, which we've already done. But if I just set that back to the default. But yeah, what we can see is it's seen by a lot of cameras above here. That's why it's blue, so that's really good. The sides will be seen by slightly less cameras because everything on this side of the screen is not going to see the green this side, but everything above is going to see the blue. So that's why there's slightly more on the top. And then as we would expect on the bottom here, it's going to be seen by a lot less cameras because we've got a big hole at the bottom, but that's fine. It's still pretty good. We're kind of seeing it within this range here. This isn't, by the way, including the mask. If you did want to view this with the mask having an impact as well, you would need to import that also. But at the moment, we're just interested in the shape. The other thing that it can show us, the angle heat map. So if I click on this button, this now creates a bit of a crazy looking pattern. So what this is showing us is when we're able to see the reflection of light, then that is almost like a 90-degree angle. So if we have the surface like so, and we have a camera here, that creates a 90-degree angle, we will give this a very high value. To help visualize this, I've put together a really simple 3D scene. So let's imagine this ball is something that we're trying to scan. And we have a camera, and we also have our ring flash. And our ring flash at the moment is connected to our camera. So if we move our camera around, as does the ring flash, and we can see the reflection on the object moving. So if this was just one camera, we're not really going to get a good prediction, but let's say we just had one camera and we're looking at this 3D object here, we're only going to be able to see this tiny little speck as our specular highlight. So it's very hard for us to see if we were to hide this, if any of this blue region is shiny, if it's rough, if it's matte. Like, we have absolutely no idea because there's only one light source. We can assume, just as people looking at this thing, we can assume that this is probably all made out of the same material, and therefore like the whole thing is as glossy as the specular highlight, as we can see here. But when we're doing a measurement, we need to be able to measure that across the whole surface of an object. So this is why we've built this coverage heat map tool. So if we're to look at just this particular object and we analyze the heat map, we'll see that we've got a quick fall off. So within this very blue region, we can definitely get a prediction. As we go towards the red, our ability to get a prediction is going to start dropping off. And when it goes completely red, like, we have no idea what the value is. The fall off here is very much related to the kind of surface that you're scanning. So if we change the material property on this object, if we made it really rough, that fall off is now quite large. So it's why you would probably look at this object and think, well, provided it's within that kind of orangey range, anything from the orange to the blue, high chance that we're going to capture it. But if this was super shiny and we made it like 0.02, so that reflection is now so small, it's kind of as small as the light source. Like, now if we change the size of the light source, that's the only way we can actually make that reflection smaller. But it's so glossy that we would have to almost position loads of these lights in 3D space in order to cover this whole thing. So in this scenario, we would say anything within that really deep blue is the only thing that we can predict here. And we could even like increase our threshold on like the display to make it really tiny. So if I go on the drop down here, anything here is saying that we have cameras where we can see that reflected ray of light. Now from above, there's a bit of a hole here. So the cameras are only ever seeing it from a kind of a slight angle, and then that reflected ray of light is going off in a slightly different direction. So this is why this area here is red. Now for this particular object, this box is very matte. So the fact that we have red isn't a big issue. It's not creating many problems. To give you some examples of how you might want to use this coverage tool, we have one that we processed earlier.